Uh, let me get this working. Okay, let me quickly check if the voice is working. Hello, hello. Okay, let me quickly check if the voice. So voice quality is good. Okay, so since I'm keeping it, I can check here as well if somebody put this one, but I'm also keeping it just to check. So first thing, let's check the voice quality is good. I kept the screen plus live recording. This is also good. So I think we are pretty much good on this one. Now I need one important thing before we proceed. We'll keep it schedule wise. We have 1 minute left to see if somebody join and then we can get started with the things. Okay. So let's see. Uh-huh. Let's see. 84 second, nobody joined. That's also fine if nobody joined. Okay, so it's 12 o'clock. I think we can get started with the first one. I will hit, I will start with the break. 5 minutes. Why? This 5 minute I'm going to introduce about what we are gonna do today. So if you're not following up, let me tell you about this live stream. We are focusing on AWS data engineer preparation. For this one, we are gonna leverage the AWS Skill Builder website where all the resources are being provided. So we're gonna do that, and we're gonna prepare ourselves within 30 to 40 days, and then directly give the exam and get the result. So today is the day number 5. We are still continuing in the session, or we are still in the course. Currently, the main course that we should be starting, we are not doing it. We are doing a basic level course that will enable us to understand what are like what is what is AWS. Second, gonna enable us to understand who are data engineers. Third, gonna enable us to understand what's the correlation between these two. And in AWS, which are the services that we're gonna leverage at which stage of data engineering. Perfect. And once this is done, then we will get back to our original course, which gonna enable us or which will help us assist us to prepare for our examination better. So right now is day number 5. When this first session will start. So we're gonna do live for this particular one for 2 hours. And 2 hours is divided into 4 sessions. Every session is 25 minutes and 5 minutes break, so 30 minutes in total. 25 minutes we're gonna talk about, we will be studying, right? We will be studying. So I'm not a pro, I'm preparing. So if you join the live session, so what's gonna happen, like you will be also preparing alongside with me. So if I make a mistake, you're gonna make mistakes, so we will try to correct each other. So I will be communicating more on this camera, on this screen with you guys. That's the first thing. So moving to the four session that we're gonna do for 25 minutes. I don't want to make it very lengthy. I want to make it very short, like Pomodoro or Pomo focus as well. So in the first one, we're gonna do revision what we have done so far. In the second, third, and fourth, we're gonna start studying for the future or the next topic that we're gonna do. If you join here, you have to go to this YouTube channel. That is your code for coin. And first thing you have to do is to subscribe this channel. And congratulations. So yesterday it was 7, somebody like unsubscribed me. And today when I uploaded this video, if you haven't checked it out, check it out. It explained the distinct and null function. So it is really good. Like under 5 minutes, you are getting everything is good. But in future, I will explain more in detail, but right now, no. So this is Postgres series. If you are interested in Postgres, you can check it out. Today we got one more subscriber. I'm really thankful for him to join in this journey. It motivates me to keep going. Okay. So first thing you have to do subscribe. Second thing you need to open the description and you need to see two main link that you have to follow. First one is LinkedIn. In the LinkedIn, I try to put interesting facts, articles that cannot I cover in YouTube. So make sure you subscribe or simply follow me on LinkedIn. Second one is GitHub. In the GitHub, I am trying to create a repository where whatever I'm learning, I am keeping it out there. So if you are interested in SQL Postgres, you can simply go and check it out. And afterwards, we're gonna start our live session for Postgres, so you can simply join that as well. So come here to AWS. Here is the syllabus. I'm going to start putting. I will start creating the day-wise files in AWS. You don't have to worry. Right now, I haven't kept. So So this is the repository right now. I don't know why there's a problem with my this ID and sometimes have this one. But usually it's usually working. I think it started working after a couple of times. So let's okay. So you simply come here on open it. I think it will work for you. I don't know. There is some problem with my this particular ID that I'm using for the live sessions. Okay. So, okay. Let's quickly go here and open our skill builder AWS. Okay, we will be simply going here. So this is that primitive or prerequisite module that we are performing. That's data engineering on AWS learning plan that we gonna learn. So simply we will sign in, and once I sign in, so what's gonna happen? It will automatically get me to the point where I have done like whatever I have covered so far in last 4 days. Today's fifth day, so it's gonna be really interesting. So now let's just done. Let's just start timer. So first session is started. First we gonna do is revision. Revision is very important in any of this thing. So let me quick it put it here. Let me bring my layer. Now resume. Okay. So once it goes in, I will show you a bit navigation and then we will get started with the one. So right now we have to start with orchestration again and automation. Then we will go to data engineering and security today, and we will try to finish this by today, most probably by tomorrow. So far, if you go with the course introduction, data discovery, AWS data services, and modern data architecture and orchestration automation, we will go quick revision to this one. Okay, orchestration. I think this is something we're gonna do it today. So I think better we go with the data discovery and then the AWS architecture. So let's go with the introduction first. Okay, so mhm, okay, so that's already done. I will tell you the brief about this one. So first one introduction, it totally talk about who are data engineer, what is AWS, and what's the correlation between these two. I will keep it very crisp. Okay. So first of all, what is a data engineer? So you understood that data, that means information, and engineer are the people who play with something, who do very technical things. So what we're gonna do, data engineer gonna do is these are the people who are responsible for transforming raw data to insightful information. They are the people who convert raw data into meaningful information or insightful information. How they do it? That is called data engineering. The process of see the people who convert raw data into insightful information, meaningful information are called data engineer. And the process of converting raw data into meaningful information is called data engineering. Very crisp. Okay. Now, what is AWS? AWS stands for Amazon Web Service. That means when Amazon provides services on the internet is called Amazon Web Services. What kind of services provide? It provide multi-directional services. But what we are interested are interested in is the services that AWS provides that complement data engineering, that fasten data engineering process, that support data uh, engineering process. And that's why those data engineers who use AWS services to perform data engineering are called or known as AWS data engineers. Perfect. So data engineer can use Python, many other software to perform this data engineering. But if you use only AWS services for data engineering, then you are called AWS data engineer. And that's something I am aiming for in next 30 to 40 days. I am preparing for my AWS data engineer associate category 01 examination. If I can pass this examination, that means I know how to leverage AWS for data engineering. It doesn't certify that I will get a job, but it will give the recruiter trust that he has done the certificate. That means he is not novice. He at least have understanding of AWS. So if you bring him into the team, he will be able to perform. Right? So this is the thing that we have to perform. So now you ask the second question is you told me that data engineering, right, is a process of converting raw data into meaningful information or insightful information, right? That's the thing. But how we do it? Question mark is this one. How we do it? So there are 5 or 6 step process that data engineering happens. Okay. So in data engineering, there are 5 or 6 steps that you have to follow in a sequential order that enable you to convert raw data into insightful information. Someday it might you might skip one and two, but ultimately in the good scenario or in most of the scenario, these are the 6 steps that you have to follow. First one is data ingestion. Okay, what is it? We will discuss it later. Right now, I'm not discussing that one. Data. Second is data storage. Third one is data cataloging. Fourth one is data processing. Fifth one is data delivery. And last and final is data security and governance. Okay, these are the 5 steps that you have to follow to be a data engineer or to perform data engineering. Okay, what are they? I will give you with an example. Suppose I think I have given this example yesterday as well, but I am giving it again just in case it is more relatable, and I think it is very subtle and it goes well with this all the process. Suppose you have your company, okay, who run interview agency. So what you do, you take interviews of different people, like be it a celebrity, be an athlete, be it a politician, be it an activist. KYC, you cover everything, like for social engagement, or you try to you want to distribute the information of different streams to the people so that they can learn from that one. So you take the interviews, okay, and then during that interview, when you ask the question, you record that audio and video, then you later uh, mm, uh, you later edit that one to make it much more meaningful, m- make it much more impactful, and then you upload to the corresponding platform, let's say YouTube. Okay. So in this whole process, imagine, let's just take an example. What you are doing, you are taking an interview. So basically, you're talking raw with someone, right? You're talking, and then you're capturing that in a camera, right? On the second stage, you bring that camera and that uh, clip into your computer. You store in your computer and then start editing. And once that editing is done, okay, what you do, you simply upload that in the YouTube channel or any platform where your users or your subscriber or viewers, they simply go to your channel and start watching that uploaded video. If you look in a micro level, what is happening? Here you are collecting information. Okay, here you are storing that collected information. Then you are processing that. Okay, you can divide into 2 steps. First one is you brought that data into your computer, and then using a software like software for editing software, you edit this one. So you can make it like this. So instead of this, it went here, storage. Then you use a software to process this one and then upload it this one. So here, what you do is storage. In the third layer, what you do, you processing, and fourth one is you deliver it to the corresponding platform where the end user can consume it. Perfect. So if you see here and relate with this, what is exactly same as this thing: data ingestion, data storage, data catalog, data processing, data delivery, and then security and governance. I will explain one by one very quickly, so you always remember that. Before we move, let me see if somebody join and they have any question to ask. Okay, nobody joined, so we are good. We will continue. So the first thing you do is not so first thing in this process, what you are doing is to talk with the guy. That means interview, okay, and then record this information in your system and then bot in your system, right? But if you look at minute level, what exactly is happening if we have to like take an example or take a reference with our system. So first thing that happens is you create this studio. You create a studio where you bring your guest and then take an interview, right? Because why is it that you have to create this system or this studio? Simple. I told you initially that you are a company of five and six people. One camera, one is director, one is your fashion artist or something, or the makeup artist. Then you yourself, if you started, instead of bringing the people into your studio, you started going in their home, what gonna happen? Tell me. Out of 100, few people might allow you, like three or four people, but rest of them gonna say no, because what you are doing, you are invading their privacy. You are getting into their house, changing everything, then you have to set up everything, and they might not be feel comfortable making a change in their house, right? You cannot simply go and rent a studio near to place. Why? Because not every time you can get the proper apartment or the place for a day or two to do shooting. Even if it does, it not might give you the impact that you're looking for. Okay, so instead of doing the work or processing at their house, or and and it is not going to be one interview, it's going to be multiple interviews in the future. Okay, so you can simply go to different places with the four or five member of crew, then bringing all the expensive items with you, right? The equipments, your camera, your lighting, all those stuff. And then this is a big expense, right? It's better if you pull that guy in your house or in your studio and then do the interview. That's much more cost efficient, right? This process this process of accessing the person from his home and then bringing him to your studio, this is called ingestion. What is called ingestion? So ingestion is a process of bringing data from multiple source data set or from the source data into your storage is called ingestion. Perfect. Now this studio that you have created where you gonna go interview, right? Do you think like what you have to do here? If it's a room, you have to make sure the lighting is proper. So you're gonna install best of their lighting, right? Then you have to make sure the camera angle are good. So you're gonna select the best camera angle that complement the person, then the overall light, and then with the lighting, right? Then you have to make sure the table, chair, or the drinks or the snacks, and the way you are talking, all the alignment are proper, right? So what you are doing, you are making sure that the person who is going to come into the studio, it is well prepared, right? That's where you're going to interview going to happen, and this particular place will become data storage. Okay, you're going to come and ask him, okay, come here, this is the data storage. Okay, now you will take the interviews done, everything is done. Once everything is bought, right, you are doing everything. Once data is done, you get all the information in this one and you store that data where? In your computer or laptop. Okay, here your computer or laptop, here the data will be stored. Okay, this is a data storage again. But, right? And then you will edit this everything based on your requirement. It's called data processing. Right? But before we move here, before we start with to do this one, let me ask you one thing. When you bring someone to do interview, are you directly gonna make him sit and you will okay, lights, camera, action, start now, right? What you gonna do is to ask him how he is. Everything good? Is he okay? Was the journey good? Did he felt anything he felt like uncomfortable during the journey? So you get to know about him, right? Similarly, when data comes into your system, you try to get to know about the data, like who dropped it, who is the owner, where it is dropped, that means location, what's the file name, what's the file format, like extension, is it Excel, is it Parquet, is it text file, it is MP3, MP4, what is it? All this information you gather it about this one and store a place. So next time when you have to know where your file is stored, what kind of a file is there, you simply go to that particular Excel sheet or that particular table or the information storage, you check out the name and you will like, okay, this file is dropped at this time. The owner is this guy, this file is CSV, it has 5 columns, 100,000 records. This is the data type of each column. Okay, now I have the better, at least basic understanding about that file. So this maintaining this particular sheet, this is called catalog. So catalog is a collection of information about data. And information about data or data about data is called metadata. Okay, so it's same as your biodata or resume that is stored here. Based on this one, they understood what kind of a candidate or what kind of data is available. Okay, so remember, metadata is nothing but same as your resume, but just give you just about the person or the data. But to really know about this one, you need to interact with him, just like how interviewers interact with the interviewee interact with the interviewers, right? So simple is this. So this is also the step that we have to maintain as a data engineer. And once you get to know him, that you will simply get started with the interview, and then you process the interview, and then you simply what you do, you edit this from that processing. And once that processing is done, you will upload that in the YouTube channel or any channel where the people can come and start watching it. So I think you are much more clear on this one. Only one thing that is missing is data governance and data security. Now, since you're running your company, that means definitely there will be people who want to steal or who want to become better than you, right? Suppose someone comes in your studio, he put his camera set or his setup at the side and start recording when the interview started. And before you can edit it, he already edited the thing and uploaded. But the question is why you allowed it? You allowed it because you never seen that guy standing there, or you were not able to find out there was a guy who's doing this. It is called data breach, or someone who hacked into your system, get into your system, or did the unauthorized access to your data and get that data. So you need to make sure unauthorized data access or data retrieval should not happen. So data security become a major concern. Second is data governance. Data governance is basically rule and regulation in the entire process that the data has to follow. For example, uh, a PII data cannot be shown. Like the personal identify information cannot be shown at given point of time. So it should be replaced with asterisk or null or empty. Right. This is the data governance. It's become part of that thing. Or you can this can be multiple layer of data governance. This just ensure data security first, and it give you the basic guidance in the protocol how data gonna flow from the entire system. Okay, so same with this one, you will here you will be like, okay, when you're gonna come, you need to make sure that every storage is perfect, no access unauthorized person is given. You make that rule. Then when interview is happening, you make sure everyone's silent their phone, and then they talk properly. Third thing is like once this editing is done, they're gonna have a review before it's uploaded to the end user. So data governance totally is a collection of rules and regulation or norms that you kept for the entire workflow to make sure that every workflow or that data flow is done smoothly every single cycle or every single execution or every single flow. That's the main crux of this one, data governance. So, so data engineer, you are very clear, right? From bringing the data into your system and then storing into the storage, then processing it. So this is your storage. Okay, then processing it and then uploading into your and platform where user can access this one, right? This is the data engineer life cycle or data engineering, or what exactly data engineer does for their work, right? We are very clear on this one where we are right now. Let's get into a bit more detail before we end this. So I talked about data storage. Remember, when you're doing any of this thing, even before data ingestion, right, you need to make sure that the place where you're gonna dump the data, bring the data, you are already prepared with this one. Though logically you bring the data, then you store it, but actually you create the storage first. When you bring this data, then you process, then you do the cataloging, then you process the data, and once it's available, you do the delivery to the corresponding platform or the places or the thing that end user want, right? Now data storage, you understood a very basic fact. The input or the raw file that we want for this entire flow, it can be of any type, can be structured like Excel or CSV, anything, right? A tabular form, or it can be semi-structured like JSON, XML, and any other, or it can be unstructured like a file, text file, or a music file, or a video file. It can be anything, right? We don't know. So since the data itself is not, we are not aware which kind of a data we're gonna ingest into our system, right? That means we need some kind of storage like the hardware, some kind of hardware that can help you to store any kind of a data, right? And that's where data lake came in. So data lake is a storage that allows any type of data to be stored. Why it is needed? Suppose you have 50 or 60 platform out there, right? And everyone is of different this one your data type. And I told you, you simply can't bring your crew, you simply cannot bring your all the your items to that place and then started to processing, right? That's not seems right. Similarly, you cannot simply go to someone's platform, bring your software, bring your tool and equipments there and start processing, because you're going to consume their resources, and secondly they won't allow, similarly somebody won't allow you to change their house for converting into a studio and then taking interview for a day, right? We're not going to allow that. Similarly, what you have to do, need to bring all the data that is required for the project into your system or into your storage. Now, if you don't have this technology, what's going to happen? That means for structured data, you need one particular software that can store structured data. Then you need another software that enable you or help you to store this kind of data. Then you need a third. Problem with this approach is if I have to look at a particular file, then I need to understand where the file is. That I need to access that particular software, then create an ID. It's a lump sum, a complicated process. Instead of putting the data into specific software, they decided to create a system where you can simply dump everything. Now, all the data that you're gonna process later using different software, different storing software, different data storing and processing software, before even that, you have one storage where everything is dumped. So you can simply go and check what kind of a data is, where it is dumping from. Everything is good. So this centralized repository, right? It becomes centralized. Every data is coming here. So data lake is a centralized repository or centralized data storage where all kind of data type can be stored. And since AWS provides such kind of services that it call S3. It means three S's. First one is simple. Second one is a storage, and since it's a service based, web service based, so its third one is service. Okay. Now after this one, you will use software that enable you to store a particular format of data type Why? Because it gives you operation to perform on it effectively. Suppose you have like Tableau data or Excel data, right? In text file. Do you think you can simply write a query or something program to get the average? You need to write a big Python program, and that's for simple average. If you have to do something complex like group by, you have to group some columns and then get the average. It will become more and more complicated. So what you can do, you can simply store that Tableau form of data into a SQL database. It will store that one in a right. And what now you have to do is ask him that to give the average because SQL is declarative language. You ask him, give me average, it will give you average within a single line. You just write a line, simple line. Select average of column from this table and it will give you. Now compare the first when the file was there and you were creating Python code, thousand lines of code now is reduced to only one line of code. You see the difference here. So these kind of software help you to organize the specific data type efficiently, and moreover it gives you easy to access, easy to manipulate, easy to retrieve insights using very simple commands. Okay. Similarly, you can also store semi-structured data in NoSQL database, right? For these type of for SQL database, AWS provide all the relation database management system across the globe, but it has own inbuilt and much more powerful database that is called SQL database that is Aurora. Okay, so I'm taking 5 minutes break. From this one, we will continue. Second one that is called it have for NoSQL is called Dynamo DB. Okay, this is for NoSQL, and for your unstructured simply S3 is the right place. You keep it there. Okay, so these are the data storage that it have. Now, apart from this one, if you want to do analytic kind of experiment or analytical type of analysis, then you can simply use on structured data. You simply use AWS Redshift, right? Shift. This will enable you to use data warehouse. Now, similarly, or similar to this one, now your storage is done. Okay, so data lake is there. You simply dump everything here irrespective of data type, and then from here you will specifically put the data to the corresponding data storage that will help you to operate on the data efficiently compared to any other data storage or data storage come processing. Now this information or this process of bringing the source data into your system data ingestion, for this one also AWS provide multiple applications or services. So suppose you want to uh, bring the file system from one computer into your S3 bucket, then simply you can use like file system or distributed file system like Hadoop, SDFS and all this one. You can simply use data sync. If you want to create one job to extract from if you want to migrate this database I talk about earlier, you can simply migrate the database in on-premise to AWS one using relational database or migration service RMS. If you want to move your file from this to the AWS one, you can simply use internet protocols that is SFTP, TFP, and that's also is provided through AWS Transfer Family. And if the data is a real-time based data or event-based data that is continuously flowing, you don't know when it's gonna come, there's no fixed time, then you can simply stream it. And for streaming, AWS has is built-in that is called AWS data hose. Okay, it's like a pipe hose or data hose, I don't know. Multiple stream going, then it will become one two. Then also help you to use some of the software that people usually use, and one of the best example is for streaming is AWS uh, Kafka. So managed streaming for Apache Kafka. This is called MSK in short. And there are a few more that I'm not diving into. Okay. Now for cataloging, what it does, there is one software that keep on running once a file is dropped or updated. It will simply go read the file and get the information like how we talk to our guest for the first time. So whenever there is a new guest or there is something happened to the guest, we automatically go and ask, right? Similarly, it goes to that file once it's dropped, or it goes to the file once there is any update or modification is made. He read it, get the information, and update that file that I told you where all the metadata is being stored. And this metadata is nothing but Glue catalog. Okay, so the collection of metadata is catalog, and the software or the service that does collect for this metadata is called AWS Crawler. Okay. Now, for suppose we have one more data processing, right, where we process the data. For data processing, I think three major service AWS provide. First one is AWS Glue for ETL. Okay, ETL. Since ETL is perform extract, transform, load, so here also you can use AWS Glue job, or you can use AWS Lambda. What is it? I am not very much sure. As we progress and we do the practicals, we will know about this one. Once this is done, or then it provides AWS EMR. E means elastic, that it increase or decrease the magnitude or the power of the system. Mapper reducer is used for data processing using distributed system. Okay, let's start the second. Okay, so what it does, there is one main computer and it is a master computer and it have multiple slave computers. So whenever the task comes, so for the task, what happen? You give the information, right? Information it will distribute to multiple computers, and when you ask to process it, it will process that particular portion of the file. Like this is a big file, it will divide into five or six. One, two, three, four, five. It will have one. It will have one and two. Suppose it will have 2 and 3, it will have 4 and 5, and it will have 2 and 1. Okay, so now it will process, it will give result for 1, it will give result for 1 and 2, suppose like this, and it will combine for whatever the file system it is coming for, and it will reassemble 1 2 3 4 5, the output, and that's how you will get the output. So this mapper and reducer is nothing but to break the file and then reconstruct the file, the output of the file. Okay, this is very powerful but expensive but you pay for what you use. And the last one is for streaming. That was Kinesis, but later it was replaced with Flink. So AWS managed stream for Flink, and it is just an upgrade version or successor word of Kinesis. So I told you, if the data is streamlined, it can come at any time. Anytime if the data came and you want to get this data move from this place to this place, and while moving you want to make the data change. Okay, it can be done on the during the stream through AWS Flink or Flink as a service. Okay, so data processing is also done, and then data delivery. So data cataloging and data governance, right? Data delivery, like these are the platform that can vary, like Excel, it can be website, it can be Power BI visualization tool, it can be anything. We don't have to. Now there are multiple AWS your services for data governance and data security. First one that I remember is AWS IAM, Identify Access Management. Identify access management, identifier, access management or manager. Okay, manager, access manager, identify. I don't remember. I for identity access manager, identity access manager. And there are few more that I don't know. But as we progress, as we learn more, we will get to know, and then I will be able to remember and tell you in depth what they are. And as we pay, because I'm going to pay, obviously, we will have more hands-on experience in future. So we will learn more in depth. But now, if you see here, as a data engineer, we were doing what we were bringing the file from or data from the source into our storage, from our storage to multiple specific storage, and then we were transforming the data and again storing in the same or different one. And once this transformation is done, then we will simply uploading that into the corresponding output where the user is able to access this one or able to consume this one. And while this is happening here, we were doing in the data lake, we are doing the cataloging, right? Okay, so data ingestion, cataloging, then here your processing, and then ultimately delivery, and during whole this one, data security and data governance. But there are few things that we are missing out. First one is this part. How will we identify the sources from which we need to extract the information, and how will know who will be our end user and how he want to have this information. Okay, this two part is not something we take care of. We, our responsibility is to know, or somebody will tell us that this is the place from where we need to bring the data. We will do this pipelining, okay, and they will tell us to whom we have to send this information, right? This two things, first identifying the sources where we have to deliver, and then to whom to it has to be delivered and how it has to be delivered. This is something it is done previous to data engineering. So if data engineering is this one, to identify the sources we need to bring and the output users and how they want to consume this one, it is done before data engineering. That is called data discovery. In data discovery, you identify the sources that will help you to complete this workflow or this project, and it also identify the end user who gonna consume it, and it will inform you how you have to deliver the data and where you have to deliver the data so end user can consume it. Okay. Again, here data discovery have few steps that has to be followed. First one is business value. So you have to convince your business that it will add value in terms of profit, in terms of reducing attrition or expenditure, anything. So you're gonna go to the business, then this is my idea, this is I'm going to perform. But they will ask you what, how it's going to benefit our business. Then only they will invest right into this project. They will be like, okay, if you do this one, this matrix gonna impact it, and in future with this matrix increase or decrease, our profit will increase or decrease. Or this project will help us to drive the data from our system into a different platform, and it will help us, these people, this end user, and we can charge them money for this one. We are just have to create one more dashboard and make it live, but the number of people that can consume this one is 100,000, and if we charge 5 euros or 10 euros subscription, we are targeting at least 500 to 1 mil of every month revenue. So obviously if it's a recurring revenue when it's a small, but for a small company it's a big thing, right? So business value, you need to identify and make your business align that this is really going to add value to the business, so they should be good to go. Second thing is, again, now data discovery. We need to understand from which platform, which storage, from which place we have to get the data that ensure this workflow or that ensure the project success. Third one, now that comes is your data storage, then data ingestion, and then data processing. uh And before that one is end users. I told you this two is comes here, right? Data consumers. Okay, these three things become the part of this one, and then they also discuss these three part, lay a foundation. Then this part is being implemented into data engineering, data storage. What kind of a storage we're gonna use, and then data ingestion, then data processing, and then data delivery based on this consumer. So we don't have to worry. This three part, you can simply remove it. It's not that much important, but this three is important. What business value it's gonna add, from which data source or identifying the data source we have to do, and who's gonna consume it. Okay. And during this time, data ingestion, data processing, data storage, data ingestion, and data processing they're gonna talk about, because they need to tell what gonna be business rules that we have to apply as a data engineer into this. That's why it become important. And once we are clear on all this aspect, then we have a entire roadmap. We have an architecture, how it's gonna flow. Then we have the data sources from where we have to bring. When we have data processing, what kind of processing we have to, what kind of business do, how we have to process the columns. Like we need to take average, we need to take item sold per day. So this way we need to understand how we need to process and what kind of information the end user want, and then ultimately we will deliver it. Okay, so data discovery is something that happened before our data engineering activities and is very crucial. It's like direct talk with the business. So this is far more important. We are done with this one. These are the people, so we don't have to worry about data discovery is done. We already talked about this one in a very detailed manner. But if you want to recap this one, you can watch previous videos, or you don't have to worry. I will create very short and concise videos for every step. Uh, uh, that will be much more clear. You can simply refer to that one. I will put a link as well. You don't have to worry on this. Now, this is the one that we have to follow: orchestration and automation option. That was from yesterday. And that's a bit critical as well that I want to revisit here. So the problem with as business increasingly rely on data analytics to make informed decision, managing the complexity of data workflow, processing and analysis becomes a significant challenge. Okay. Without efficient coordination and automation, data pipeline can become fragmented, error prone, time consuming to manage. Okay, if you look into this two perspective, like first one is just an introduction where it says as business increasingly rely on data analytics to make informed decision, managing the complexity of data workflow, processing and analysis become a significant challenge. So what it says that as the need for the refined data, for the processed data, for data analytics, or to make the decision increase, complexity as the back will also increase. And if complexity increases, the workflow that you have created, it will put pressure on you. Okay. And how it gonna impact on this one is such this gonna something he right here. Without efficient coordination and automation, data pipeline can become fragmented that I was talking about. So if you remember how things were there, it was technical modular, right? It was modular. Ingestion was a process, data storage was one process, data cataloging was one process, and data processing one was one process, and then data delivery was one process, and one process was entire end-to-end data governance and security, right? So suppose when I say model is like a creating a one class, one function, whatever you want to understand. Okay. So in data ingestion, I will write a code that you have to go there, bring this data, everything, and then store it. Done. This one piece of code you have written, you store it ingestion or data ingestion for project whatever it is xyz dot py. You store it. Okay. Then you create another file for data processing for data process. Okay. You start writing the code, access this one, then you create a function that is gonna access the table, blah 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 blah. Right. Then you create that file. Now what happened? You run the ingestion file, then you run the distillation, your processing file, and then what you will run data delivery file that will put the data to the corresponding platform. But if somebody asking you to run it every hour, do you think you are available for 24 into 7? If you are available, what happened? That you have two, three people that are doing in shift. You every hour one is going and running each and every one by one manually. But there is a time the network might go down, and before you realize you are taking more than time, or the person who is responsible for the run for like 100th time, suppose uh, tonight someone was responsible, right? And somehow he slept or his laptop was not working. Now 12 midnight, who he will call? That means till next 8 hours nobody gonna run the fight, so it's gonna be big problem, right? That's what he's talking about. If you don't coordinate between these modules, or if you don't do the proper automation, like it will automatically run, you don't have to go manually and run. You simply automate the process of that every file will run automatically one by one. The ingestion module will run, data storage module will run, then data ingestion will run, then data processing will run, data catalog, everything one run one by one in the workflow order, okay, without disturbing one another. It's synchronized, right? So this process of turning the modular into a pipeline, this is called orchestration. Okay, orchestration is nothing but to make your modules in a sequence or in a particular manner that it makes sense end to end. Create end to end workflow pipeline. This is called orchestration. Perfect. So what is automation? Automation is nothing. You don't have to manually interfere with this one. Okay. How? Let me give you an example. Even if you create workflow, what do you have to do? You have to manually go and run it. You have to manually go run it. Now, instead, you created a program or you use one of the software where you set the time that every hour you run it. Now you sleep, you go for vacation, you are not feeling well, you are in hospital, or you are going to play, dance, you do anything. Automatically every hour this particular event will trigger the workflow, and workflow start executing these modules one by one. So it's like a Python code. Like the Python code, what it will tell, it will have the path and the Python script you have created. It will automatically take this one, run it, get the answer, that whether it's successful or denied. Success, it will run then the data processing and one by one every. If submitted failed, it will get the log, it will stop the workflow that it won't run the other files and simply send a message to the developer, dude, there's a problem, simply check this one. And you check it, it will rerun it and it will become part. So automation is like when human intervention is not required, everything is automated or it will automatically done by the computers. So this is very interesting. So if you see, look here, orchestration is the process of coordinating multiple services or modules you define and manage the workflow of data through a series of steps. How simple is that? It's just it's just enable you to run multiple services or multiple uh, Python code or the codes or multiple modules based on a logical sequence to transform or to achieve a proper data flow or to transform data from one phase to another phase or to transform raw data into process data or business required data. This is workflow. Okay. Now automation refer to using tool and services to automate a repetitive task related to data ingestion, processing and analysis. Okay. So something that so automation is suitable for simple repetitive tasks. Orchestration is needed for a complex workflow, including. Okay, so simple as that, right? Best example of automation. Automation. What is automation? Automation means when you make your some work that is manual and repetitive into a program that does that work for you. You don't have to go there. You can simply use your creativity doing something. Best example I given you that every hour you have to do it manual trigger, right? All it does is to trigger this one. So you create a macro, you created a Python code that does that. It will automatically schedule every hour. So event based, like every hour it is tick, it will automatically run the workflow. So what you did, the manual work that you have to do, you simply replace with this particular thing, right? Second thing, uh there are many other examples. I'm not like remembering such an example that I can give you for automation. Mm, because ultimately the second thing was like you automated the workflow, right? And workflow will automatically take care of self execution, right? Now that self execution you were doing is also taken care by automation. So simply automation means when some task that is being very repetitive can be replaced with some programmer code or something that computer can handle without your intervention, you do it. Okay. Be it using coding, be it using some software, something, anything is fine. Okay, let me give you an example. Like, for example, we are using Pomodoro. That's the best example of this one. The actual Pomodoro comes like a clock. People have to do it manually. So every 20 minutes they have to do it manually if they are not forgetting. Similarly, if you look here, what I have to do it like every time it's over, I need to stop it and then restart it. It is not doing automatic. What now I can do? I can ask the developer that can you put one more here clock that says how many minute of session I want, how many minutes of rest I want, and then how many times it has to be repetitive or it has to be done repetitively. So suppose I write like 25 minutes of session, 5 minutes of break, and then I have to do 4 times. That means 25 and 5, 30 minutes for one session, right? Complete session. And it's gonna be done 4 times. That means 30, 30, 1 hour, 30, 30, second hour. That means for 2 hours, it will automatically adjust everything. So at the start, 25 minutes go, it will ring the bell and it will automatically start the next 5 minutes. Then it will stop, ring the bell, and automatically start the next 25 minutes. And then again, it will ring it, stop, and start 5 minutes of break. Right now, I'm doing that manually every time. Okay, I'm coming here, I'm pausing it, I'm clicking it for the break, long break, whatever it is like. But with that particular change, it will automatically do that thing for me. So that's how automation work, where you try to save your energy or to use your energy into something much more meaningful and replace that repetitive work with some kind of automation. So automation is nothing, just replacing that manual work with the help of code or some software, and reducing the human intervention or completely erasing the human intervention. So for orchestration and automation, there are many services provided that I am not aware of or never used it. That's something I want to use it as part of our learning. But the first one is AWS function. Even I don't know what is it. Step function is a virtual workflow service to orchestrate and automate workflow pipeline process. So automate workflow pipeline is like simply schedule it based on your requirement. You don't have to go and figure it as per your need. You simply tell the automator or the scheduler to schedule it, and it automatically run it at every 15 minutes, every hour, every once a day, whatever it is. Okay. So there is AWS Step Function. Step Function is a virtual workflow service to orchestrate and automate workflow, pipeline, and process. Step function ensure tasks run in the correct order. It's as simple as a orchestrator. That's the basic need or basic thing that orchestrator had to do. Orchestrates ETL workflow by connecting. So how it does orchestrates ETL workflow by connecting Lambda function that extract the data from source, transform it, and load it into database and data lake. Okay. So the best example of AWS step function is it take if somebody has created ETL mechanism. So ETL is the same, it's its fancy name of that workflow I told you, that it identifies identifies data source, it extract information, brought into the system, transform it, and then load to the end user for consumption. So what is happening? Three step: extraction, transformation, and loading to the final user's platform, right? So end user is never interacting with the storage of data lake and the places we store it where we are processing the data, right? This is called ETL. And for this one, I told you for ingestion, there are multiple AWS services. Then for processing, there's multiple ones. But you can use AWS Lambda to perform end to end. Okay, it can extract, then it can transform, it can extract, ingest, then transform, and then load it. So AWS Lambda can do it into multiple steps. So each step is like a code, like Python code. Okay, in AWS Lambda, it can use its ID to simply access it and figure that out. What it does, you will inform me that I created three job in using AWS Lambda. First code access the what is it? Let me show you on paper. That will make much more sense. So in AWS Lambda, I created three jobs. First one, second one, third one. A job basically you can say code. Okay. First code it access the source and it ingests the source into my data lake. Second one, it does two things. From data lake, it will bring the data into my data uh, warehouse. So it's S3 warehouse is Redshift. Okay, and then it start processing the data, and that data got stored into database. Okay, and for this one there is multiple database it offer as a service, but Aurora is in build house. in build database, so we will use it. So second processing does this thing, right, from here to here. And the third processing, it bring this data from here to the corresponding platform or storage where the end user can consume it. Okay, this is delivery. Now I run this first, then I will run the second and the third I will run. But using AWS Step Function, Lambda function and the Step Function, what it does, you tell him that I want to execute Lambda functions in a particular logical order that it perform this entire end-to-end series. So what I want him that you execute number one. Once the job number one is done, you immediately run the job number two, and when job number two is done, immediately run job number three. Perfect, great. And it does the same. Now you don't have to manually go and one, then two, and then three. It will automatically take care of it. Suppose it failed here. Earlier, what happened? It failed. You have to look and come here job. It's a cumbersome here. In this design, virtual design, you can simply say that my job failed. It's visually uh, more better to analyze and understand what is happening with your data, like, with your flow. It's a success here, it's a error or a failed. When you know that job 2 has failed, then simply you will go to this function and check where it failed using log and the stuff. Okay, or you can do it more than this, right? Now what you can do, if in case any of this failed, you trigger one notification email. If it fail, it will send a notification. This time it doesn't fail. If it doesn't fail, so it won't say. If it fail here, it will send an email to your developer. And it does send to the developer, and developer find it that my job has failed. For step number two, it will go and check, okay, it failed. It has some log? No. It will simply go to the actual where job is created and simply do the thing. So now let's take a break of 5 minutes. See, I'm manually doing it. If it can be automated, my life will be easier. Okay. For next 2 hours, I don't have to come here and do this thing. Let's take 5 minute break, come back, and then we will talk. Before that, I will check if somebody joined and they have any questions on this one. Okay, so nobody has any question. So let me quickly check on my Twitch as well if somebody joined and they have any questions. Okay, nobody is there. So simply let me write it down. Let me take a break and quickly grab some water, and then we will get started. Oh, hello, buddy. Well, let's start. This is the third one. We were learning about orchestration and automation, and we get to know that AWS Step Function is a workflow, a virtual workflow services to orchestrate and automate workflow, pipeline, and process. So, Step Function ensure tasks run in a correct order. Simply, the bare minimum requirement for from an orchestrator. So, it also runs batch job on data, AWS Glue, AWS AMR, and other services. Process streaming data by connecting Lambda function, processing data from Kinesis data stream or the Amazon data firehose for real-time analysis. Simply, what exactly is happened here that we are leveraging AWS function to call the stream processing AWS services like Kinesis or Amazon data firehose for real-time analysis, or simply the batch jobs on AWS Glue, AWS EMR, other services is simply calling that. So processing streaming data by connecting Lambda functions, processing data from. Okay, so the more we will read it, we won't be able to understand it at the moment because we haven't practiced it. But the overall is to understand that AWS step function is an orchestrator. The AWS Lambda. So AWS Lambda runs code called Lambda function. So it runs the code that is called Lambda function that we were talking about, right? There might be some code that enable us to do data ingestion, then data processing, and then data delivery, right? We are not sure how it is happened, what the structure, what language is used, or is it like uh, something like uh, software where the interface is there, we simply have to put the value and it will automatically take care of the other thing. So without provisioning or managing server, okay, we don't have to manage it. It's a serverless, you can say. It will automatically take care of the server, where it gonna run, how much server resources gonna occupy, everything. Based on how much you run, it will automatically send the bill in your account. So combined with step function, lambda function can invoke combined with step function. So step function is nothing but this one. Lambda step function and the lambda function, okay? Step is like simply taking one step at a time. So it's basically means orchestration. So step function is happening like orchestration. Lambda is a function that is that like during that step, every step, okay? So lambda run the code that we understand without provisioning or managing serverless, okay? Combined with step function, lambda function can invoke AWS services, microservices, perform tasks to that are part of orchestrated for workflow. So Lambda function can invoke AWS service that I was talking about, right? In here it was already suggested that AWS Lambda function, it can execute the code that was written here. But what it can do is Lambda function can invoke AWS services that we were talking about. For batch processing, it might be able to call AWS Glue, AWS or Amazon EMR, or for ingestion, it can call any of the function or services that AWS provide. Like for processing, it can call your Kinesis, or there was one more, right? Firehose. Okay. So microservices and perform task with the part of orchestration workflow. Simple is this. So Lambda function can invoke by event from data source like Amazon S3, MongoDB, or Kinesis data stream, process incoming data in a real time. Agreed. So since is kind of a real time, is you create an event. If somebody drop a file or modify a file, automatically for that particular directory, send a message to this particular lambda function ID, and it will start executing the particular or corresponding process we have established. Okay, this is called automation. Now I don't have to manually go and check file every now and then. It will automatically does the thing for me. Okay, this is automation. Step function can be used to orchestrate multiple lambda function. Okay, for error handling, retires, and visualization. Same as step function. Okay, so in the step function, what is happening is using multiple sorry okay, this is the step function can be used for orchestration multiple lambda function that we were talking about. So simple is lambda function, these lambda function can perform a specific task, so they are action prone. Step function is the collection of this lambda function in an orderly manner, in a logical flow that it execute based on the user design of the workflow. Simple. Yeah. So again, the step function is because it's a step, right? One step at a time. So it's an orchestrator. It orchestrate the workflow. Lambda function is an executor. It execute a code. It execute something that we want to do. Okay, lambda function can be used in an event driven architecture with service like AWS SNS and AWS or Amazon SQS. Okay, perfect. So I told you, right, you can simply invoke a function code or Python code, suppose using certain event, like suppose 1 o'clock strike, it will execute. 2 o'clock strike, it will automatically execute. Okay, so it's event based. Secondly, it can happen if mail come, it will automatically trigger a function that scan the mail and analyze whether it is a spam or not. What is happening? It is automated. We are not touching it. It is automatically taking care of everything. So now Amazon MWAA. So Amazon manage workflow for Apache Airflow. Same. So see here the difference. This is inbuilt, like in-house build. It is built by AWS. This is built by Apache organization. They are using it in providing a managed services. It is a service that they're providing by managing this software. They are not claiming that this is our software, but we are providing it as a function. Why? A lot of organization might be familiar with this one, even if they want to shift to cloud-based services to reduce infrastructure cost. They are familiar, or the entire architecture is familiar with this Airflow. They are not familiar with AWS function, and they're not sure whether it's compatible or not. They don't want to take a risk. So they want a platform where they can go online or they can go on cloud. Then they can use the same or similar, not similar, but the same softwares that they were using on premise, so the entire workflow can be replicated exactly same, and without touching anything, everything workflow or everything flow or everything work like same as on premise. Okay, so they may demand that we want this software, so that's why they introduced that you can run Apache Airflow in our system, because we are also managing this. Okay, we haven't created this one, so it's not in build or in-house, but we are managing it. So that's why it's managed workflow for Apache Airflow. simply this can configure. So this also can be used to ingest, process, transform, and load the data into database data warehouse. Amazon MWAA can also be used to run queries on the data for query analysis. That's something we will figure out as we use it, and as part of learning, I'm also keeping a slot of learning Airflow. And then I will also definitely gonna learn AWS MWAA, manage workflow for Apache Airflow. Amazon MWAA workflow handle dependency support parallel running. It's same as what an orchestration can perform. It can be sequential, it can be parallel, it can dependency, it can throw an error if a particular block fail. Everything that. Okay. And since it is managed by a cloud-based service provider AWS, it can automatically scale up, scale down, scale horizontally, um, simply based on demand. Now, what is Event Bridge? So, Amazon Event Bridge, that means I think it is in-house built service, is a serverless service used to build event-driven application. Okay, so it is built, used to build event-driven application. It employ loosely coupled application that work together by meeting and responding to event. Okay. Okay, event bridge can ingest event from various sources and then route them event to different target for processing action. Athena can run SQL query and Lambda function can drive customer processing. Event coming into event bridge can invoke workflow and oh, oh, I think I know what even this one. I think this can be a part of this one, or this one, or they are the same thing but different, same but different functions. Okay, okay. You can ingest event from various sources and then route this event to different target for processing or action. So simply, I told you an example like if a mail comes in my system and then automatically it will my execute my job to scan and understand whether it is a spam or not, or you have to move it to spam, right? But how this communication will happen? The email came and automatically this is stopped. So you need to create a software that constantly maintaining my inbox, and once a file try to get into my inbox, it automatically triggers, okay, there's a file now, and it will send this message to this particular software or the code that this is there, you execute this one. Okay, so it will start executing. So there is one software by Amazon that is called Event Bridge that does that. When event happen, it automatically send a signal to the corresponding service, and that particular service that was designed for this task will take initiation and start executing. That's the Event Bridge. And there are three services like Event Bridge, Amazon SNS, and Amazon SQS. SNS SQS. Okay, that makes sense. Amazon's simple notification service is fully managed messaging service with Amazon SNS. Application and service can send message to multiple end point simultaneously through SNS topic. So this is just a variant of Event Bridge. Here, instead of signaling and is start executing that directly, right? It send a message. Okay. And it also send a message, but it send a message in a queue. So it will store the message in a queue, simply go and take one by one. Okay. So Amazon SQS is managing queuing service to send, store, and retrieve multiple messages from various size asynchronous. Multiple user or system can submit analytical job and task by sending a message to. Okay. And here application service can send message to multiple endpoints simultaneously through this one. Okay, so let me go here. So event drive, what is event drive? Is say event, right? So event bridge. What it does, if some event that you define happen like the clock hit 1 o'clock or 12 midnight, right? Or a file drop, anything, any event happen you describe, it will automatically take an action you define it. Be it start execution of a file or write in a file, anything. It does that one. So event bridge is like event action software. Event happen, and action occur corresponding to this one. One second one, Amazon SNS. That is a simple notification service. It will notify if some event happen. It will send a message to the endpoint. The third one is Amazon SQS, simple queue service. So what happened? There will be one storage queue. You know the data structure like queue. So whenever some event happen, it automatically put that into the queue that you have defined. Okay. Suppose like this. Suppose this is the one. You came in and some event happened like 12 o'clock. You send a message here that you need to execute the file 12 o'clock for execution. Now what happened, after some time, another event happened, somebody dropped the file. So it also push a message that the file is dropped, and this will push this particular notification front. Then something happened that the new file was updated. So it send a message that file is updated. This will push this file inserted front, and then this will push ahead. That is 12 o'clock is done. So similarly, this way multiple messages will be accumulated in a queue order, like queue like line. And whenever you come, you will see this message is their top message, then the second message. You will start retrieving them one by one and assigning to the corresponding person based on your need. Okay. So now you don't need a event base. You can simply put it event here. You simply read it. Once there is a file, you read it and simply do the processing or whatever the task you need to do. So basic difference is event action based. This is one notification sending and it is queuing the notification. Very basic difference, but huge difference. So based on your circumstances, you need to understand which feature you want to use. Now let's move to zero ETL that we learned. Okay. So two technologies can make orchestration and automation even more effective in data analytics workflow, zero ETL and serverless architecture. Okay, serverless architecture is literally they want to they don't want data engineers, they don't want anyone to work on literally. They want to remove everyone. Okay. So what is zero ETL is referred to an approach for data ingestion that minimize or eliminate the need for ETL processing. With traditional ETL, data needs to extract from the source system, transform or clean, and load into data warehouse or data lake. This process can be time consuming and complex to develop and maintain. You have to develop, man. Like even if you don't want this to happen, you need to process it, right? You need to transform the data. You need to run the code and do this thing. With zero ETL integration, data can be directly queried from its original source without requiring data movement or transfer. Dude, the same thing I told you that you need to bring all the equipments, everything to that place. This is this can work only when your data sources that AWS is talking about is hosted on AWS only. So this approach, what they are claiming to be very effective in this thing. Trust me, they just want to increase the business by bringing all the other data sources into the AWS system. That's they want. That's it. Okay. So if you bring that one on AWS, then it makes sense because now you are part of community. Instead of like that, you go to that place and this one. Now you told them that you are now partner. Now since you're partner, you have to give me house for a day, just a day. You go there and do the editing and shooting video. You simply take the interview and everything, and then you come back and start editing. Okay. But the same thing, you have to make him partner. That means you have to bring that data on AWS. And if you're not ready, I think the zero ETL will fail for you, right? Until unless your system that you are hosting is capable enough to handle any kind of request, and then you allow it that instead of doing that, simply come here, run your query, process it, and whatever data you want, simply bring it. But but ultimately, it's drilled down to the same thing that every data is available there because sometimes data is not the ultimate data that you want is not as simple as that. Simply go and process it. At times, you need. to bring the data from multiple sources and then you process it. That's too complicated. If you start doing everything in the source type, problem it will lose the clarity. Suppose for example, from the same cluster of my source data, I want to create five different data sets. So in the first one, I can create five different pipeline. And if one fail, I can understand. In this architecture, even if I'm creating one pipeline, it is automatically going into my system. And problem with the processing part, you can divide into multiple steps. You can understand where it is failing. But if you run everything at the source, how are you going to store it? That's my second question. If suppose somebody is using RDS, okay, they are using their own platform, okay. The problem is like you're using someone else structure, and you need to see it. Sometimes when you are processing it, you have to store in between temporary data. That means you need to have a full access to their table. That means somewhere it might breach that permission level of thing, right? When you have a complete access to read and write into his system, and God bless you if somehow you run very incorrect query like delete or something, and since he have access of like creating dummy tables for this one, until unless you then again create another flow, schema flow for this person that he can create there, and it, so how many schema you gonna create then? 1,000 people will be using the same schema. I think somewhere it's like putting everything. It's a hodgepodge. I do agree that this makes sense to me, but it will somewhere make the things very hodgepodge. Everything is to be done on a place. Done. It will become really hodgepodge. So Amazon Athena, like with Athena data storage, you can simply run query SQL on this one. Mm, yeah, you can run it, but trust me, dude. I ran the Athena query. If data is huge and it's not properly stored, it's gonna take a lot of time to like process it. Until unless you store the data in Parquet format, that is partition format, then it would be much easier to do that. But still, I don't think it's really that compatible. But this is my personal experience. So I'm not giving it the final verdict or something. Okay. So Amazon Redshift is a data warehouse again for some ETL task processing in a real time at a high throughput, but it does not need, because it does not need a stage in S3. The need for ETL task is eliminated. So who's gonna do processing in that case? Mm, it can reduce your step, but ultimately you have to do partial steps. Replicated data from some Aurora source to Amazon Redshift in a real time analytic zero ETLs. See, I got it. So they are trying to make it event based. I got it. I got it. They are doing in the real time basis. But if somebody try to update that time, what gonna happen? Because update query is very expensive in a warehouse, right? Or how they gonna handle that one? Even if it says that they can do it in a live, but I need to see how powerful engine they're gonna use at the back. And if my data is in terabyte, and you're asking it that with the database Aurora, you can simply go and it will automatically change everything based on the system you, at the end it is ETL. It's just like you don't have to specify using some Java and stuff. You simply write it the simple pipeline code within the software within this databases or the storage. It will do it automatically. But again, dude, I'm not sure. Like I can't think of, I can think of scenarios, but I need to understand. Until unless I do things with hands-on, I cannot give you exact, or until unless some I read some papers and understand. What I'm thinking, actually, I think they must have taken care of this one, but I want to understand from performance perspective. Tomorrow I do the same thing for IoT. Okay, I want to bring that data into my database for every day before I move it to Redshift, and if they do immediately, And I found out that I want to create multiple more columns and I want to update and do the things. Dude, terabyte of data you update. God bless that system. It can be done, but at what cost? That's the question, right? What cost? How much computation gonna take for that? How much power are the Amazon gonna provide for this one, just for one update? So I think there will be definitely caveat, and they will ask you to make sure that if you are running update query or something, you have to be careful. Amazon Redshift auto copy from S3. Simply what exactly they are doing or they're talking about zero ETL is not exactly they are removing ETL. They are trying to make it inbuilt function, inbuilt facilities within certain AWS services that does that particular that E or that I or some kind of a thing. But majorly I can see it is always like abstraction and loading. It's not about transformation. For transformation, you have to do it by yourself, right? So the thing is very simple. For ingestion, you create one lambda function, right? Then for transformation, you do one lambda, and then this one. Three jobs are you creating at a time, and then you're maintaining it. What is this? You don't have to bother. If anything change on the source, even somebody drop update, it will automatically fetch and give you the data. Automatic event based. Okay, you don't have to worry. Okay, event it does. Okay, once the data get refreshed in your table, okay, once data get refreshed in your table, what you can do is set up an event bridge. That my ingested data that automatically filled it using this one of the services. You trigger this one my orchestrator AWS Step Function, or you can simply execute my Lambda function. Processing done. Once processing done on my table, one event automatically trigger that it will send the file because this is the same thing like event based. Something happened and automatically copy the file. It will copy the data into this one. So what is exactly happening? You are basically the stuff that was visually present there, it is now being abstracted within those tables. But the biggest thing gonna happen is like it will remove visibility. If the way I'm thinking of architecture. So what I can what see same person gonna not gonna work on the same thing for lifelong. There will be new people that will onboard. Now they have to figure out everything at what condition, what event this is happening. Because you have make it like zero ETL. So there's no need for actually this thing as well, like orchestrate everything. So they won't be able to understand the workflow. Then they have to read the documentation. Trust me, that's the worst thing to understand. Like that's the worst thing to trust me. Then they have to read every page, everyone. Then they have to understand. Okay. So you're missing out. So I think somewhere workflow itself means that the complete visual of how the data is flowing, from where it is flowing, become much more evident and easy to understand about the data flow rather than reading the document. But that's my personal understanding that I understood through this one. I'm not sure how good it is, how bad it is, but let's see how it goes. Okay. One thing that I can understand so far is open source service. What is exactly this thing is? Okay. So I am reading on this Amazon open source service. Open source service has zero ETL integration with Amazon S3 for querying data directly in S3 without extracting to OpenSearch. This improved query performance for log analysis and use case. So this improved query performance for log analysis use cases. So it's not saying that it's completely usable for all the cases, but log basing. Okay. I really don't know. I think I need to deep dive into it because as per my understanding, if you're simply querying a data that is available in data lake as a file system, right? It is not stored firstly very effectively based on the data sets. And if it does access it as a reference, it has to extract then do all those things and this one. It does reduce the overall headache of like creating pipeline and all those things, but somewhere it will increase the processing time, processing power and the stuff. And somewhere it has to be compromised. That I feel. Maybe it visual visibility, be it uh yeah, it can. I think I can't answer you much in depth. Is based on my experience, but I think I need to look into this one. And I think the more we will deep dive into this one, we have better understanding. And don't worry, in future we will create our own projects using this technology. Then we will have a better understanding and we will do better at this one. Now, serverless architecture, what is it? A serverless architecture is a way to build, run application and services without having managed infrastructure. Your application is still run on the server, but all the server are managed by. It's as simple as like you hire some, for example, the best example I can give you that you can easily understand this one. Serverless architecture are extremely cost effective because you only pay for the time you use the code. Efficient orchestrator workflow depends on significant on the serverless application. Many AWS services have serverless option or can be used in serverless workflow. Let me give you the best example of this one. Suppose what happened, this is your company, right? This is your beautiful company. Okay, and here is your company's logo, tag, whatever it is, right? Don't worry. Then the floor and everything. So in this floor, this is your guy robot work, and he is your guy who is responsible for infrastructure. Okay, your IT infrastructure. Now what happened? You are running your query. I'm giving a live example, the actual example, real example from my time, and the time I was working for some company. I created a job. Okay, it was basically automate the things. Okay, automatically when the job comes, when the people get refreshed, it automatically create that messaging tool that I was talking about, Amazon SQS. I was using some other software called Solace. Okay, same as Amazon SQS. So in a queue, it will send a message, and when the message is done, it will read, and based on this one, it will trigger multiple jobs in parallel and process this table. But what was happening? The capacity that was provided to the project, only 2% was provided to this in this job, and the worst part is it was streaming, and they didn't allow it to use streaming, uh, streaming your services, because that time I think that software doesn't have that one, or we were not, something happened. I think we were restrained on the time. I don't know what happened. We were given instruction that you need to use current architecture to accommodate this one. So this was suggested that we will send a query here, we will store it, and then we will simply do the thing. So based on this one, I created this system, but the problem was that it was real time. There were more than like 1,000 jobs that was updating every single day. So it was a drop and create for the job because of certain reason of the infrastructure. They have to do that way. Now comes here when job is when table is dropped, a new table is created with the new name, all this schema, else sub everything came. I have to pick it up, put it here, then process it and then send it to the cloud. Okay, we were using Azure. Now when it was dropped, we have this message here. When using an automator, I did first in first out. First message will go in one of the executor, then the remaining will go to the other executor, and then it will process. Okay. So since we were this one serverless architecture, okay. So now 2% is allotted for this one, like 2%, right? The percent is nothing. Okay, if the job is high. So what was happening? Five, 1 out of 5 every execution was failing because of memory issue or the resource allocation issues. Okay. So what we does, we ask the guy to increase it to 6%. 6%. And after that we never face this issue. But this was done by this guy Robert, right? We need to reach out and based on our job, everything we need to analyze, and then we have to tell him that this much resource need. So if a person is not technically sound or architecture, memory resourcement, and everything, it will be hard for him to estimate. And his play of like hit and trial, or you provide abundance of this one. But on the other hand, AWS take care of this one. He says you don't have to worry about infrastructure. We will let your query run, and as we figure out that he need more resources, it will automatically increase the resource capacity as the job execute automatically, or automatically decrease if you don't need it. And you will pay for this time only. Here we have to pay this guy and all the resources that we install, the infrastructure and everything. But here we just pay for the time we use this one, AWS, done. And that's how we lose one more course. Okay, so this is called serverless architecture where you don't have to worry about infrastructure. AWS take care of it, and it will increase and decrease the capacity of infrastructure based on the, the job execution. So we don't have to worry. So there are multiple AWS services that run on your serverless architecture, or it can be made into this one. Lambda function, primary serverless AWS service, it one code called Lambda function without provisioning that we already learned it is serverless. API gateway, I don't know what is it, but you can create RESTful and HTTP APIs. Okay, I forget. Application interface or something, I don't know. That can integrate with Lambda function. You can build serverless application where the business logic is run with this one. So simply API, dude. So simply what happened with the API. So this is your AWS, and inside you have created one account for your company, say A, and inside this one you have written the core Lambda function, and it runs and executes certain function, and it can give you some values. Okay, so there is a client here. He runs his computer, send a message that I need to use this particular function, and he send a request. How it send a request? Through API. API will hit this computer, goes to my this particular Lambda function and execute and give me the answer. And then answer I can send it back to this guy. And this communication from this particular computer to my AWS is done through API. Then Amazon DynamoDB is NoSQL database. And again, is a serverless. S3 is a serverless because it can get SNS is a serverless. SQS is serverless. Redshift is a serverless. EMR definitely is a serverless because we don't know. AWS Glue is a serverless. MSK managed service stream for Apache Kafka serverless offers serverless option. So you can do manually as well. You can simply define that this much structure or infrastructure I needed. But yeah, for streaming again, I'm not sure which services it I need to run, but it can be done. So to learn more about you can simply visit this one, this one. We are not going it because we have invested more in this one. So now which option are correct use of AWS step function step against orchestrator in the data analytical workflow? Okay. So coordinate multiple AWS Glue, extract, transform, and load jobs and process data from different sources, load into this one. Coordinate, that's right, it does coordinate. Orchestrating a machine learning workflow that involves data processing, modeling, and this one, it can orchestrate. Storing metadata, no, it doesn't store, it invoke executors. Perform batch, it never perform. Creating an access person, no. Analyzing, curating output from multi, no. Storing metadata. Okay, storing metadata about the workflow stages and storing metadata. Oh, it does. I told you it informs the information. If it fail, it will send a message. Perform no, creating no, analyzing no. Okay, I was wrong. It doesn't. Okay, got it. It doesn't. So what I thought metadata is about that particular module that it is executing and storing about the information. But I did it wrong. Performing batch processing job performing batch processing job on data stored in AWS. S3 using AWS batch. It doesn't provoke. It doesn't performing batch process. It doesn't perform. It invoke. I think my English is bad. I didn't understand this one. This because AWS your step function it invoke. It's like event based. Like it invoke whenever this start, it will hit it and it will simply go and trigger this one. So performing batch processing job on data stored in using AWS batch. It doesn't provoke. It invoke the job. I don't know why it gonna perform. I think I need to understand a bit more, but as per my understanding, it invoke, it trigger performing batch processing job on this one using AWS. But I don't know the right way of saying this. It invoke AWS batch processing that you created through in event based trigger. But again, which option are benefit of using zero ETL approach on AWS select? It require building and maintaining custom extract. This one pipeline between data sources. It is streamline data architecture and reduce data engineering effort by automating custom extract, transform, and load process. It provide real-time insight through real-time or near real-time data access. It provide real-time insights. How can it dynamically scale Amazon S2? It automatically run audit to regulatory compliance, optimize cost for other benefit of zero thing. Okay, which can be benefit it required building and maintaining custom extract this one pipeline between data source. This is not the benefit, right? It is streamline data architecture and reduce data engineering effort by automating custom. Okay, it provide a real-time data set through the data access. It dynamically scale Amazon S2 instance with a list. But it's automatically there, right? It automatically run audit, it check for regulatory compliance. It optimizes cost for organization because it is based on actual usage in data processing end. I think it does make sense. Yeah, I was right. So the number of steps that it want to perform using these services it reduce. So it is AWS aim to eliminate the need of custom ETL pipeline by using integration and automation between AWS data and AWS analytics services. The same thing I was talking about. You need to host everything on AWS. Now AWS has have your data. But but that's the thing again, right? Sometimes you don't load the data that is really sensitive on cloud because there's a high chance of data breach in case. It's online, buddy. Which option best describe a benefit of using serverless architecture for data analytics workflow? Which option best describe a benefit of using serverless architecture? They eliminate the need of data encryption at rest or in transit. They deploy fleet of E2 instances to run analytical workload. Serverless architecture are not suitable for batch or script. Organization can optimize cost by paying only for the resources consumed. Serverless architecture are built based on actual usage rather than provision capacity. That's true. Did I not start at that time? Wow. Anyways, we have only 10 minutes left. Now, today we were supposed to start this thing. I think we can't do it because we try to recap everything, and I think that's very important and simply going ahead without having a proper understanding. So data engineering, security and monitoring. Thus, security, we talk about the importance of security in AWS data analytics workflow cannot be overstated. Any breach or compromise could lead to severe consequences, including data theft, financial losses, damages of reputation, and regulatory penalties. Plus, there can be downfall in the business. Security should be addressed with the following: access management. You cannot simply give access to anyone using IAM, identity access manager. Okay, or management, I don't know. I need to see. So regulatory compliance, many regulation like GDRP and HIPAA mandate that organizations securely manage data and adhere to privacy and security best practices. Non-compliance can result in heavy fines. Used or using managed service for AWS has also been common compliance control and auditing capacity. Okay. So further, I think GDRP, I think I need to do it, learn more on this one. Now, sensitive data protection. Data analytics offer involves large volume of sensitive data, such as personally ident- identifiable information. So PII, personally identifiable information that can cause a huge thing: financial record, health record. These are the protected from unauthorized access and theft or leakage. AWS provides services like encryption, masking, and identity and access management. Okay. Data and network security. AWS service like security group, network access control list, firewall help restrict network access and secure this one. Okay. Data auditing. It is essential to be able to track the origin, transformation, and flow of the data from the source to target. You need to know where the data comes from, how it was processed, and what system have access to it. With the Glue data catalog, you can store the data definition, physical location of the data set, add business element attributes, and track how this data has been changed over the time. So data auditing is very important. Oh my god, that's too much. Access management, IAM, ACM, regulatory management. Okay. The same thing that we learned there, we we are talking about the monitoring gonna come. It will take good amount of time, no doubt. Tomorrow, I think when we're gonna come for 2 hour of session, we will directly start with this one, and it will take complete complete this one 2 hours, and then we will go to the assessment conclusion. Right, tomorrow I think most probably we will be able to complete everything. First 1 hour this one, then this one. It's not gonna take that much time, but I'm good. I feel good that I did a revision on this one. And once that is done, then we will simply have a subscription tomorrow. And then we will simply go with our data engineering on AWS Data Lake. From here, our actual, we will get to interact with the database and the stuff, and then we will do. It says 4 hours, but I took literally a week. But I'm happy with the results, and I hope it can expedite process much more better here. And once the remaining four is done, then we will get back to our original. Mhm. Okay, 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 okay. So tomorrow is gonna be interesting. I think tomorrow or day after tomorrow at max, this will be short. Then we get started with the other things. A day or two at max. So this is done. Uh, I know I'm wrapping it today early because even if I start it, it won't make sense because I want to make it continuous rather than starting halfway through. So with this, I will wrap today's video. Let me see if somebody connected and they want to check any question or something. Okay, so nobody joined. With this, let me take the call and close for today. See you tomorrow.